Now let's find the coordinates x, y of the midpoint M of the line segment that joins the point A, x1, y1, to the point B, x2, y2. In the figure, notice that the triangles APM and MQB are congruent. Because, well, first of all, we have some parallel lines. We have two horizontal lines. We know that horizontal lines have a slope of 0, and parallel lines have the same slope. So AP is parallel to MQ. We also have a pair of vertical lines, MP and BQ. They both have undefined slope. So those are segments. Let's do that. So those segments are also parallel. So MP is parallel to BQ. And when lines are parallel, certain angles have to be congruent, right? So this is our transversal. A transversal is just a line that intersects two other lines. So it intersects both the green lines, right, at one point, and it intersects the blue lines at one point. So when lines are parallel, angles that are in the same relative position, in this case above a line and below the transversal, are called corresponding angles, and they're going to be congruent. Likewise, we have another pair of corresponding angles. In this case, we're to the left of a line below the transversal, and those would have to be congruent. So that gives us two pairs of angles that are congruent. Also, since M is the midpoint, right, and remember a midpoint divides a segment in half, AM has to be congruent to BM. All right? So that's enough to prove the triangle's congruent. So triangle APM is congruent to triangle MQB using angle, side angle, triangle congruence. We could have proved it another way, but that's the way I chose on this particular example. Right? And so we have our triangles congruent. So if the triangles are congruent, all the corresponding parts are congruent. Right? So we do know that AM has to be equal to BM. Well, notice we've got some coordinates in there. So let's see if we can use the coordinates to solve for a formula to find what x and y are. All right, so since AM is congruent to BM, that means the difference in the x coordinates is going to be congruent. So that means that x1 minus x is going to equal x2 minus x. I'm going to actually just change the ordering of that, sorry. And you know why I'm going to change the ordering? Because I don't want to have to use absolute value bars. If I take x minus x1, is that going to be a positive number? So the absolute value would have been right for me to say x minus x1. Now it would be the same, right? Because the absolute values would be the same. But if I subtract something, actually I think I had it this way. If I subtract something smaller from something larger, right, I'm going to have a negative number. And based on our diagram here, x is larger than x1. So that I don't have to use absolute value bars, let's just subtract the smaller from the larger. All right, so in this case, AM is going to be x minus x1, and BM is going to be x2 minus x. All right, further on the right, the larger you are. All right, so now let's solve for x. Let's add x to both sides. So now I have 2x minus x1 equals x2. I just want x, so let's add x1. Because x1 and x2, those are just some coordinates. I just don't know what they are. So now I've got 2x is equal to x2 plus x1. I didn't want 2x, I just wanted x, so let's divide by 2. That means x is equal to x2 plus x1 divided by 2. So this value here, I'm just going to take whatever x2 is, add it to whatever x1 is, and divide by 2. Well, that gave me what x is, but I also want to know what y is. All right, so remember, though, AM is still congruent to BM. All right, so let's subtract the y coordinates. And we don't want to use absolute value bar, so let's go in the right directions, large minus small. So AM would be y minus y1. And BM would be y2 minus y. Want to get the y's on one side, so let's add y to both sides. So now I've got 2y minus y1 equals y2. But I don't want 2y, I want y. I don't want 2y minus y1, right? So let's add y1 to both sides. So now I've got 2y equals y2 plus y1. And I really only wanted y, so let's divide both of those by 2. Y equals y2 plus y1 divided by 2. And now we know what y is. And guess what? We just derived the formula for midpoint. Right? So now you're not going to have to derive it again, but you might have wondered, where did this formula come from? And here we did an example with a pair of congruent triangles. And now that gives us the formula for midpoint. So the midpoint of a line segment A, which is at x1, y1, to B, which is at x2, y2, is, we're going to add the x coordinates and divide by 2, and add the y coordinates divided by 2. In other words, we're taking the average of the x coordinates and the average of the y coordinates. Let's do an example. Show that the quadrilateral with vertices P at 1, 2, Q at 4, 4, R at 5, 9, and S at 2, 7 is a parallelogram by proving its two diagonals bisect each other. Now the tricky thing on this problem is you've got 4 coordinates. Make sure you choose the right ones, right? Because only 2 pairs of these are diagonals, and some of these are sides. So I'm just going to do, actually, you know what? I have a coordinate plane on like the next page. So instead of me drawing a very makeshift, horrible looking coordinate plane, why don't I just grab one, because I know there's one right here. And of course now I have to go back. There we go. I did not give you a coordinate plane, so you will have to just make one. All right, so 1, 2, there's P. Q is at 4, 4. R is at 5, 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. And S is at 2, 7. 3, 4, 5, 6, 7. So it goes P to Q to R to S and back to P again. Whoops, and I sort of missed the mark there going back to P, but it's close enough. And 1, 2, 3, 4, 5, 6. Whoops. Now once I was playing around with now I messed up my side. So there, try to make it, the orientation's a bit off on this board. Good enough, right? I think you can probably figure it out. Oh, you know what I could do? I'm just going to graph those one more time. Q is 4, 4. R is 5. 1, 2, 3, 4, 5. I think that's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah. And then 2, 7. Now I can make a straight line. There. There we go. All right, good enough. This is P, Q, R, S. The diagonals go from 1 vertex to a non-adjacent vertex. Can I get a line and a color so you can actually see it? Yes. Okay. So that is a diagonal and that is a diagonal. So we want to find the midpoint of PR and the midpoint of SQ, the non-adjacents. Oops. I put M for midpoint, and then I just put which one we're looking for. All right, so the midpoint of PR, all right, we're going to take the x coordinates and add, and then the y coordinates and add. So this would be 1 plus 5 divided by 2. All right, that's going to be the x coordinate of the midpoint, and 2 plus 9 divided by 2. That would give us 6 divided by 2 and 11 divided by 2. So that's 3 11/2. Let's see if we get the same answer for the midpoint of SQ. If we do, right, then the diagonals are bisecting each other. In other words, this is the same length as this, and this is the same length as this. They're dividing each other in half if that midpoint has the exact same midpoint. All right, so SQ would be, and I'll start with the Q. So that would be 4 plus 2 divided by 2, and 4 plus 7 divided by 2. Well, that gives us 6 divided by 2 and 11 divided by 2 again. And indeed, we have 3 and 11/2 again. So this is a parallelogram, since both diagonals have the same midpoint. Diagonals, so SQ bisects. Actually, let me see. I'm going to try to say it succinctly. Both diagonals have the same midpoint. Both diagonals, let's just not use our names. Both diagonals are bisecting each other. And PQRS is a parallelogram. There we go. We have shown it to be true. And I think that's my last midpoint problem. Yep. Thanks for watching. And now you do some problems on midpoint on your own. Bye for now.